one example. Suppose that a function f at 0, the value is -3, and whose derivative, the value of whose derivative is always less than or equal to 5, means this function is differentiable everywhere. How large can f2 possibly be? How large can this value possibly be if you this problem into a moving particle? You will see at time t equals 0, whose position is at -3. And the velocity of this moving particle, whose velocity at most 5. Okay, maybe meters per second, perhaps. So if we use the highest speed, the velocity to move, then obviously at the moment t equals 2, t equals 2 will be f of 2 plus 5 times the time interval is 2 minus 0. Sorry, 0. 7, perhaps. Okay, this is by our observation. How to solve this formally? Okay, by mean value theorem, we know f of 2 minus f of 0 over 2 minus 0 equals f prime c, where c is some value between 0 and 2, 0 and 2. So we have f of 2 equals f prime c times 2 minus 0. Sorry, f of 0, yes. By this condition, f prime of x is less than or equal to 5. Of f of 0 is -3. And this one is less than or equal to 5. So maybe 7 or 7 meters is an upper bound of f of 2. Can this equality hold? Yes. If we consider the specific function equals -3 plus 5, 5 times 5x, 5x. Then this function, obviously, f of 0 equals -3. And the f prime of x is the coefficient 5. 5 is, of course, equals 5. Therefore, equals or less than 5. So function that satisfies these two conditions. And this function at x equals 2 is 7. Good. So here we just, by mean value theorem, we ensure f of 2 is less than or equal to 7, but we don't know whether 7 is achieved or not. But by considering this specific function, we know, oh, yes, it is. Therefore, 7 is the largest possible value for f of 2. So how large can f2 possibly be? So the largest value of f at 2 is the number 7. Okay. Here just shows 7 is an upper bound. We don't know, maybe less than or equal to 7, of course less than or equal to 10. So here you just can say 7 or 10 is an upper bound, unless show number 7 can be achieved. Okay, so otherwise we cannot say 7 is the largest possible value. So this section, I told you, mean value theory is maybe the most important theorem when you want to explain some property of a given function which is differentiable theoretically. This is the most important one. Of course, for computation, maybe the fundamental theory of calculus is the most important one. But for theory, the theory of calculus, maybe mean value theory is the most important one. Okay, the next section. Okay. What derivatives tells us. Tell us about the shape of a graph. Here, a graph means maybe a graph of a function or a graph of an equation. Okay, usually the graph may be increasing, may be decreasing. So let's review some definition. Suppose I is an, for simplicity, we consider an interval. We see that f is increasing on this interval I. by definition, means x1 is less than x2. Implies that f of x1 is less than f of x2. That is, if a function is increasing or increases on some interval, means this function preserves the order. Order means a smaller one whose value will be smaller, larger one whose value will be larger, preserves the order. Okay. So, graphically, this behavior of this function, if continuous, will look like this. x1 is less than x2. Then f of x1 is less than f of x2. So some students, they prefer to say, the graph of this function from the left to the right, getting higher and higher. Yes, but getting higher and higher is very bad usage. But use yes, addition, subtraction, multiplication, division, and is less than or equal. Okay, maybe more precise. Okay. 所以什么叫做一个函数在某个区间上面是递增或者严格增？定义是说，在这个区间上面，如果 x1 比x2小，则 f(x1) 比f(x2) 小，就是任意的两点，比较小的函数是比较小，比较大的函数是比较大。那这样讲，其实我们知道这个实数里面就是有运算加法跟乘法，或者说加减乘除，再加上两个重要的关系，小于跟等于。递增函数就表示这个函数在这个区间上能够保存次序，就是大小关系，能够保存大小关系。次序或者叫做大小关系，英文叫做 order，O-R-D-E-R order。OK， preserves the order。OK， decreasing。We say that a function f is decreasing on this interval line. Means in this interval line, if f of xy is less than x2, then f of x1 is greater than, reverse the order. Okay, reverse, not preserves. Geometrically or graphically, if x1 is less than x2 means x1 on the left of x2, then f of x1 is greater than f of x2, or higher than f of x2. So intuitively, if this function is continuous, whose curve will be lower and lower from the left to the right. Okay. So the increasing and the decreasing can be defined or described by inequalities. Inequality, so inequalities. This is a definition. Okay? Before university, you memorize many formulas and the result to solve problems. But back to the foundation. Simply addition, subtraction, multiplication, and division is less than the order and also the quantity equals. Very good. Now, suppose, further, the real value function f is differentiable. Whose derivative exists? Then what the derivative can say about the shape of this function means increasing or decreasing. So the next theorem is called increasing-decreasing theorem or monotonicity test.